Okay, welcome back. So what we're going to do in this video is walk through how to find the competitive market equilibrium in one particular market, given our real core assumptions, so our consumers' preferences and budgets, and our producers' production function and input costs. Now, before I dive into this, I just want to say for a moment here that I'm about to do a ton of algebra. This is going to be a big math problem. And I don't want you to get too lost in that algebra. The goal here is not for you to follow every step and make sure that you can reproduce it. The goal is to really see the connections between all of the work that we've done so far and to really understand what we're assuming when we draw supply and demand functions. Supply and demand curves, right? What we're holding fixed, what we're allowing to vary. Okay, so with that said, let's think about trying to understand competitive equilibrium in the market for avocados. We can say that we've got, let's say, 100 demanders, all of whom have preferences for consumption and avocados, right, where consumption is just everything but avocados, of C plus 8 ln A, right? We can say that the price of consumption is normalized to 1, and our consumer's income equals 100. And then we've got suppliers with the production function, f of Lk equals, let's say, 4L to the 1/4 K to the 1/4 minus 4. And input prices, W equals 16, R equals 1. Cool. I want to highlight here, right, I'm not telling you how many suppliers we have, because that's going to be a result of our market equilibrium, right? Suppliers can enter or exit the market depending on whether they're making any money given the market price. Cool. So let's try to find, so first of all, what we're trying to do, right, is we're saying that if we take all of these demanders, each of them is going to demand some number of avocados on the basis of price, and we're going to be able to say that we get some demand curve like this, right, QD as a function of P. And all of these suppliers, right, are going to supply different numbers of avocados on the basis of price. We're going to get some supply curve, QS of P, and our goal, right, is going to be to find P star and Q star where our market is in equilibrium. So to start with, let's try to find our demand, because this is going to be simpler, right? If consumers have these preferences, we can say that our MRS is going to be du dc over du dA, right, which is just going to be 1 over 8 over A equals A over A, right? If we find an interior solution, which to save time, I'll just say this is going to be an interior solution. We'll set A over 8 equal to PC over price of an avocado, which from now on I'll just call PA. So this is going to be 1, and I'll say A is going to be 8 over P, right? So each individual is demanding 8 over P. We sum horizontally to get our market demand. So our market demand is going to be 800 over P. Cool. Right, so we can say QDP equals 800 over P. And what we're saying here, right, is as long as the price of other stuff remains constant, our preferences remain constant, and our income remains constant, consumers are going to buy 800 over P avocados at any price P. All right, awesome. So we're halfway there, right? We found our market demand. Now we just need to find our market supply. So if we want to find our market supply, right, what we need to do to find a long-run market supply curve is we need to figure out the price, right, where firms are going to be producing their optimal output and earning zero economic profit. In other words, right, we're going to have a set of long-run cost curves like this, right, marginal cost, average total cost, and we're going to want to find a combination of P and Q, where the firm is producing their optimal output, right? So where marginal cost equals P, and where the firm is earning zero economic profit, so our average total cost equals P, which is of course going to mean marginal cost is going to equal average total cost, which is going to equal P star, right? One thing I want to note here I'm using a lowercase q rather than an uppercase q because this is the output of a specific individual firm. So in order to find this, or in order to find where marginal cost equals average total cost, we of course need to start by figuring out what our cost function is, right? We know what our production function is. We need to know how much it costs to produce Q units as cheaply as possible. So let's start there. So our goal, right, is to find C of Q, which is going to equal W times L of Q plus R times K of Q. Right, so what we need to do to find this is find our optimal L and K for producing Q units of output as cheaply as possible. So let's start with our MRTS, which is going to be dF dL over dF dK. Right, this is going to be, I'm just going to blaze through this algebra here, L to the minus 3/4, K to the 1/4, over L to the 1/4, K to the minus 3/4, which is just going to be K over L. Awesome. So what do we do with this? Well, we know we don't have corner solutions, right? So we can go ahead because if K was 0, we'd have an MRTS of 0. If L was 0, we'd have an MRTS of infinity. So we can go ahead and set MRTS equal to W over L. I'm sorry, W over R, which is going to equal 16. So we can say K is going to equal 16L. From here, we can plug into our isoquant, right, to figure out, if we know that capital equals 16L, we still need to know how much K and L we need to produce Q units of output. So we'll say Q equals 4, L to the 1/4, K to the 1/4, minus 4, right? Plug in 16L for K to get Q equals 4, L to the 1/4 times 16L to the 1/4 minus 4, right? So that's going to give us Q equals 16 to the 1/4 is 2, right? L to the 1/4 times L to the 1/4 is L to the 1/2. So 8 L to the 1/2 minus 4. That's going to give us, right, Q plus 4 squared over 64, right, over 8 squared is going to equal L. And then we can get K, right, by just saying K equals 16L. So K of Q, L of Q. K of Q is going to equal Q plus 4 squared over 64 times 16, which is going to be Q plus 4 squared over 4. Awesome, awesome, awesome. So now we know how much labor, how much capital we'll use to produce Q units of output. So that's going to make it very easy for us to figure out how much it costs to produce Q units of output. So how much does it cost to hire Q plus 4 squared over 64 workers and Q plus 4 squared over 4 acres of land? It's going to cost, right, WL, so 16 times Q plus 4 squared over 64, plus RK, right? So plus 1 times Q plus 4 squared over 4, right? This is going to be Q plus 4 squared over 4 plus Q plus 4 squared over 4. So this is going to be our final C of Q is going to be, of course, just Q plus 4 squared over 2. I'm going to expand this out to be Q squared plus 8Q plus 16 over 2. Awesome. So now that we've got our cost function, right, we know how much it costs to produce Q units of output. How are we going to find our long-run supply of avocados? Well, as we said before, right, what we need to do is find where marginal cost equals average total cost equals price. Right? In other words, we need to figure out the quantity and price where firms are going to be producing their optimal number of avocados, right, without earning any profit on their avocado production. So what we need to do to find this is we need to find our marginal cost, we need to find our average total cost. So marginal cost is just going to be dC dQ, which is going to equal, right, derivative of Q squared over 2 is going to be Q, plus the derivative of 8Q over 2 is 4. Average total cost is going to just be C of Q over Q, right? So this is just going to be Q over 2 plus 4 plus 8 over Q. Cool. So MC Q equals ATC of Q at Q star, right, is going to tell us Q plus 4 equals Q over 2 plus 4 plus 16, or I'm sorry, plus 8 over Q, right? So that tells us that Q over 2 equals 8 over Q, right? Q squared is going to equal 16. Q is going to equal 4. Q star is going to equal 4. Beautiful. So when we're producing, right, when we're producing our optimal choice, earning 0 profit, we're going to be producing Q star units, right? Each firm is going to be producing Q star units. So how much is that going to cost us? We'll say MC of 4 equals P star, right? So that tells us that 4 plus 4 equals P star, which is going to equal 8, right? So what did we just say? We said that each firm is going to be producing 4 pounds of avocados at a price of $8 a pound. When that's the case, firms are going to be earning 0 economic profit, so there'll be no entry or exit into or out of the market, and we're going to have our long run supply. So if this is how much each firm is going to produce, how much is the market as a whole going to produce? It'll produce as many avocados as you want at a price of 8, as long as avocados are a constant cost industry. In other words, as long as our wage stays 16 and our rental rate stays 1, right, if we wanted to produce 4 million avocados, we would just have 1 million avocado farms, each of whom is producing 4 avocados. If we only wanted to produce 4 avocados, we would have a single avocado farm producing just 4 avocados, right? So our supply is going to be just a horizontal line, which I'll draw by saying 0 if P is less than 8, right? No one's going to produce anything at a price below 8. 0 to infinity if P equals 8, and infinity if P is greater than 8. Yeah? If we had a price above 8, we would never stop having new entrants into the avocado industry, right? We would just be swamped with avocados. Everything would turn into avocado. It would be the avocado apocalypse. And just to be clear, right, what this is telling us is, as long as we have a wage rate of 16, a rental rate of 4, and this production function, right, we're going to have as many avocados as we want at a price of 8, no avocados at any lower price. So all that's left to do, right, is to say now that we have a demand curve and a supply curve, we just need to figure out where our market equilibrium is going to take place. Right? So if we graph this thing, we're going to have a demand curve like this. And we're going to have a supply curve like this. Right? Right? Perfectly horizontal supply curve, downward sloping demand curve. And what we're looking for is our Q star and our P star. Well, there's one thing that's obvious right off the bat looking at this graph, right? Our P star has to equal 8. There's no other way, right? The only alternatives would be to have demand of 0, which we know we're not going to have, or to have demand of infinity, which we're not going to have. So we know that our price is going to be 8. As a result, all that's left to do, right, is to figure out our quantity demanded at a price of 8, which is just going to be 800 over 8. So we're going to have a Q star of 100. Make sense? Right? Suppliers will provide any amount of avocados at a price of 8. At a price of 8, demanders ask for 100 avocados. So our market's going to be in equilibrium when we have 100 avocados and when we have $8 per avocado. And there we go, right? We're done. We found our market equilibrium. There's just a couple things I want to add to this, right, just for fun, because we can get some more information from what we did solving our supplier's function. So the last thing I want to do is we know that Q is going to equal 100, and we know that little q, right, the output for each firm is going to be 4. So therefore we're going to have, right, 100 over 4 equals 25 farms in operation, right? Farms growing avocados. We can also say, we know that each farm used L of Q equals Q plus 4 over 64 workers, right? Or 8 over 64, or 1/8 of a worker. So we know that our total labor demand, right, when we're growing 100 avocados, is going to be 25 times 1/8, right? Which I'll just leave as 25/8. Right, and we can do a similar thing to figure out the total number of acres under cultivation. So essentially what we're saying here, right, just to sum up everything we've done, we've said that as long as we're holding constant, right, the price of other goods, consumers' incomes, the number of consumers and consumers' preferences, we're going to have a demand function of 800 over P. As long as we're holding constant the wages of workers, the rental rate of capital, and the production technology of firms, we're going to have as much output supplied as we want at a price of 8. That's going to result in an equilibrium where we grow 100 avocados, right? We use 25/8 workers, and we're going to have a price of avocados equal to 8. So what we're going to do next time, right, we're going to do in the next video is we're going to think about how does this problem change if we don't believe that we can hire as many workers as we want at a wage rate of 16. In other words, right, as we talked about at the end of last time's lecture, what if it's inaccurate to assume that we can expand output as much as we want, right, out to infinity, without changing the costs of our inputs? Great.